Hello everyone, welcome to my video. This time I am come up with a very interesting project of ML based audit system for a D2H company for it and the use case of D2H. I will tell you that as I have worked earlier with a D2H company, so at that time what we are doing those days we were doing audits through Excel, and then also later we automate that in those KRIs into system. So I have turned this those rule based KRIs now to ML based, machine learning based. So these KRIs are machine will be generated by machine learning models. So let's quickly check the first slide. You can see I have named it as ML based D2H audit system using classification and regression both. So what happened is, as we know that classification is 0, 1, true, false in binary. In our use case of D2H audit system, we will say that whether it is correctly charged or disparity is there. Similarly, for regression, it will produce continuous values, as you can see here in the pic below. So continuous value means it will predict the revenue values. I will explain later in a detailed manner. Okay. So let's check the highlights. Revenue assurance based audit for D2H 4 KRI reports. There are 4 KRI reports that we will generate. I will show it through rule based also, and then using classification and regression also. So next we can further check the other highlights as well. So basically you should know I was in revenue assurance department. What assurance department does is that it identify, analyze, mitigate, and prevent revenue leakage through various measures. Okay. So as I was stating, there were four KRA reports. So first is relocation charges reconciliation. It I will show it through rule based also plus classification also. Then it is extra validity reconciliation, rule based also plus classification also. Revenue charges reconciliation, rule based also I will show you. And this one also I will show you through classification and regression. So what are the importances of each model we will learn. Then the fourth one is landline charges reconciliation. That is also I will show through rule based plus classification. Okay, so this is from the first slide. Okay, so let's quickly move to next slide. Okay. So yeah, so what it is stating, it is stating traditional rule based versus machine learning based auditing. So there are problems with manual and rule based auditing. Let me tell you, fixed rules cannot adapt to different revenue structure. So this is the main problem. Threshold based. There are incorrect discrepancies. Means high false positives, incorrect discrepancies flagged. I will give you the example. So this is time wastage. We are, the system has generated the report and that is incorrect. So time wastage. High false negatives means missed revenue leakages. So the ones who has to be, checked, the report has not been generated. So we have missed the revenue leakages. So what is machine learning based auditing does? It automate classification or automatic classification of discrepancies. Means ki is no manual intervention. It will learn through the historical data, and it will adjust the model will adjust the tolerance itself, threshold itself. I will tell you in next example. Dynamically learning pattern instead of fixed threshold, as I just tell you. Accurate predictions of expected revenue using regression. So regression model, we will check. I told you that we will for revenue report we will use the regression model also, which will tell the what should be the expected revenue. Okay, let's go to the next slide. So this was the example. High false positives means incorrect discrepancies flagged. Time wastage, as I told you, because these discrepancies are incorrect and not meant by our business problem, not fitting on our business problem. Suppose a rule flags any revenue mismatch of above 2% as incorrect. So if it's a simple example, I will tell you 2% means for $1, 2 cents. So I we have made a rule that if more than 2 cents, flag it as incorrect. Means discrepancy. So if a customer actual charges 10.23 means $10.23 instead of $10.20, it might be flagged incorrectly. Why? Because it is more than 2%. So even though this variation is acceptable in certain cases, so unnecessarily for 1 cent, there will be many cases flagged in a report. See, in a real scenario, in a real world problem, a real world scenario, I mean, how much cases will be there like this, and you can just see example amount like 10.23 cents, 10.24 cents will be flagged by a rule based KRI, but ML based will understand it by past pattern and incorporate tolerance. As I told you, if 10.23 in front of 10.20 is written as 1 means correct charging, so it will understand that 10.23, 10.24 is a tolerance. It is showing correct labels are 1 means correct charging. So it will not generate the those cases on report. It will not flag those cases, I mean. So you see, this is what is the advancement of ML over the rule based systems. And they were, yeah, so making system to not flag such discrepancies if in past they are were ignored and training data as such patterns. So what I was saying you, let's see the example. Oh, very good, what a beauty. See transaction one. So I was saying more than 2%. So expected amount that should is 10.20 as per our business logic. 10.20 amount has to be deduct. The amount is 10.21, so deviation is 0.1%. Both rule based KRI and ML based ignore it. Why? Because it is less than 2%. Strictly for rule based, and ML is based on pattern also. So for again 10.20 is expected, but actual deduction is 10.40. So what happens in in these revenue edits, the ideology of revenue assurance department to check and make these KRIs that customer should be properly charged. It should not be overcharged or undercharged. If it is overcharged, then customer dissatisfaction is there, and if it is undercharged, then a revenue loss for the product company. Like this D2H use case that we are doing. So you can see here for second transaction number, this 3 1 transaction 3, 10.40 was detected instead of 10.20, but we have in rule base we have given +2% is okay, so ignored by this, ignored by ML. And again then 10.10 $45 means 2.5% deviation, means 25% cent is more. Rule base will flag it, but ML will ignore it. If the past, as I told you, the past pattern is acceptable, it was correctly charged, so it will ignore that, but it will not do because it is rule based, it will flag. Similarly, for 11.50, it is very much deviation, like 12.7% deviation is there, so both will flag it. Similarly, $15 is of 10.20 amount that has to be deducted is very much 47% deduction deviation, then the both will flag it. Again, plus minus, I was telling you, like now 10.20 was about the system has to deduct, but $10 was deducted, so it is less, -2%. It was ignored by both because 2% we have given a threshold for rule base as well. So 9.95, you see here, now their deviation is -2.5%. Even for a little bit 5%, it will be flagged. So unnecessary, how many cases, like in a real scenario, 1,000 cases are there. So the guy analyst who is checking will be shake his head. So so that's scenarios I am telling you. So it will be ignored by ML based because in if past it was okay, it was the label as 1 means correctly charged instead of 0, so it will ignore it. Similarly, when $9 is there instead of 10.20, so it is very high. Those will be flag, and this is very very They should be done because there is high discrepancy. Okay, let me move to next slide. Okay, so before going to next slide, let's understand it through Excel. Excel, you can see here the data is like that. The customer ID is there, some deferred revenue field, current date, current revenue field is there, current revenue, calculated revenue. So calculated current revenue will come in the file, which will be checked by the calculated revenue. This is in rule based. This calculated revenue column is made by the formula. So labels we have, I told you, we have generated. So this is the data we will give to the model, classification model. The labels are there. One stands for correctly charged, zero stands for incorrect charge. So model will learn itself. We will give some feature also, because you have to understand, the classification or regression. These are prediction models. This calculation, simple calculation that is being done, that this formula calculated revenue we put to the rule based KRI, as we did, as we were doing earlier. But in ML models and AI models, we have to give features to understand the relation between this current revenue and calculated revenue, so that they can understand and they can make decision on their own. This is not formula based, that they will learn the formula, or deploy the formula, and then they will understand that according to this should be correct. No, this should be, because formula is already there in previous rule based systems. So prediction model, there in, like I was telling you, like classification 1 0, I have segregated between these different cases. So the model will understand one is correctly charged, zero is incorrectly charged. So let me show you example of the, as I was stating before. Like let's take these two examples. See, these are very high value after decimal. I will just make two place after decimal. So yeah, if I hit the OK button, so yeah, you can see here now. See, current revenue D column, this one 7.41, and this is 7.44. So what I have correctly charged. So this is in previous patterns I have put like this, the 3 cents. Okay, 6.36, 6.39, it's okay. Okay, so model will learn that even for 3 cents the amount the adjusted for the correctly level of correctly charged. So discrepancy of this much, it will not flag as zero. Next time when on new data, this is a training data. If this is training data and your model is learning the relationship between the current revenue and calculated revenue, so these difference between the 3 cents will be a tolerance rate for the classification model. So it will not highlight this. How much cases will be like there in, because in rule based simple forward, you can see here, if I make a formula, this minus this. See, difference is there now. The rule based means calculation based systems will flag it, that simply it is not matching. So the analyst who will be sitting, he will say, yeah, what is this? Uh, this should be understandable by the model. And today's necessity is that we need models in to understand the data by itself. So this is why machine learning or AI based models are capturing the world. So this was a simple example I want to convey. So okay, let's move. Okay, so similarly for high false negatives, those are the cases that should have been flagged but missed and caused revenue leakages. So simple example, that a customer was supposed to be charged $50, but due to a system issue, they were charged $45. Instead of $50, charged $45. So if the rule-based system only flags discrepancies above 10%, which is $5. So if it is, if the rule-based system is designed, given the threshold that highlight the cases above $5, then which is exactly 10%, which is exactly $5, will might go undetected. So ML models, I told you, detect patterns in past revenue mismatches and can catch these discrepancies that fixed. rules miss. So let's take example right now. Transaction case one, actual charge $50, customer charge 45. So instead of 50, only 45 was charged. Deviation was 10%, means $5. So missed. Okay. So but ML detection has flagged it. Okay. So why? Because we make the rule greater than $5. So equal to $5 was missed in this first case. Secondly, second case you can see here charge has to be $50, but customer was charged 44.55, means $44 55 cents. So deviation was like that, but was missed. Why? Because this figure is rounded. Then also it become $45. Then it is missed by rule base, but ML has detected and flagged it. Similarly, for case 3, actual charge is $50, then again $44.50, again missed by rule based. Why? Because if the system will round the figure something, the then if we round this figure again, then it will become something like $45. Then flagged by ML but missed by rule based direction. Then in case 4, when for $50 only $40 is charged, customer is charged, then you can see deviation is 20%. Then both are flagged because it's a very high deviation. So for you can understand that by these scenarios that even 50 cents difference is something is there. But if you take only 1,000 cases are simple cases are done by this, then $500 something per day revenue loss is being applied to company organization, I mean. So I will tell you, this is not about only 2 3 cents problem or 2 3% tolerance problem. I mean, let's go to next slide. So here you can see also that machine learning model, as I told you, if we add feature it will learn from the patterns. So scenario you can see here, some promotional offer is there for free 1 month validity for new subscriber are getting 1 month D2H free. So rule based will fail here. Why? Because it will flag. It will not account for promotional benefit. So it will flag a missing charge. But machine learning model, from past promotion and customer behavior, understand that these are validity extension without charge. Similarly, retention discounts like you first 3 months free for retained customer. If customer are retained, they are given first 3 months free. System will charge everyone and flag a missing amount of, ठीक है, three for 3 months missing amount, the rule base will show. But ML will learn from the past discounting pattern and not flag. Similarly, plan migration, customer downgraded to lower plans. If your customer moves from $50 to $40 plan, rule base will say that revenue is lost. But machine learning model will understand plan migration trends and identify that downgrade is not an issue. Okay, so it will not flag. Again, last scenario is volume based discount. The customer who is getting 12 month subscription gets special discount. So what rule based method will do? It will check base pricing only and will miss the these discounts the subscriber is getting. But ML will detect the pattern of price variation for long term subscriber and then incorrupt include them into predictions. So now understand with this, for better understanding, like for in month January, expected charge for customer subscriber was $50. Actual charge applied was $50. Very good. So rule based will flag it correct and ML will flag it also correct. Then in February, the expected charge for subscriber was $50. Actual charge applied was $50. Correct. Both rule based and ML have said they are correct. So in March, what happened is expected charge for subscriber was $50, but actual charge was zero. So rule base will immediately say that it is a revenue loss because it doesn't understand free period. But ML knows this is retention discount, it will not flag. So see, like so many cases, like for per day, like a big D2H company or product based company, so many cases are there, thousands or more than 10,000 cases. So ML knows. if you have add some feature like I show you in Excel now, if you add some more columns, and you will say that this is 1 month validity, this is 2 month validity free, and another column which will say that this is retention benefit for this much months. So what happens is, and the last labels are there, correct and incorrect. So ML will understand those features, and it will not flag those cases as discrepancy. But a rule based, you can know that it is just a rule based, condition based. So this is not dynamic like ML. So again, for April, there is a, you can see expected charge of $50. Actual charge applied is $30. The rule base will flag it that this is a partial payment, but ML recognize that there is some loyalty discount pattern. It has some loyalty discount has been given. So similarly, again, we can say that $50 expected, and then actual charge $50, then correct by both. So for understanding purpose, I give you, this picture to understand you more effectively. So what are the key takeaways? Learning understand context from past data, and rule based just applies hardcore rules and generates unnecessary alerts or reports. Okay. Yeah. So understand these. These are the four KRIs. So first one is relocation charges reconciliation. When someone is applied for the D2H to be relocated to some other premises. So scenario is it should be charged $50. Any charge less than or greater than of $50 will flag a discrepancy. So relocation charges, the explanation is there. Even I already told you. So extra validity reconciliation is for 10 days only. Any extra validity beyond 10 days will flag as discrepancy. So customer are no more validity other than this are not allowed, because it will help us. This KRI will help us identifying overcrediting issue. Then revenue charges reconciliation is there. So calculated revenue versus current revenue will be compared, and significant deviation will flag a discrepancy. What it will help revenue calculated based on customer plans matches the actual revenue generated. So it will indicate the revenue issues. Similarly, landline charge reconciliation, $5 should be applied. Any charge less or greater than this will flag a discrepancy, because landline charges are constantly applied at standard rate. Discrepancy indicate potential billing errors. Okay, so we will see now on the production code itself. We will generate the system based KRIs first, then machine learning based. And let me show you the formula also for revenue charges reconciliation. Okay, so here we are on coding screen. So you can see here this is calculation based revenue assurance, 4 KRIs for the D2H company use case. This code has a report generation feature as well. Okay, first we have to understand that these are only 4 KRIs. I have demonstrated the KRIs is much more uh, for the revenue assurance audit purpose. But firstly we will understand there are three files. This is first file. We are importing combined audit data file. So it will have the customer IDs and other details. Let me show you. This is the file. I have made very limited data to understand audience, technical and non-technical, in a very easy manner, because in real scenario there are much more columns. There are very high count of there are high count of columns. So these are customer IDs. You can see some base plan charge is there, and actual charge is there. And I told you base plan charge is there, actual charge is there, how much was charged, expiry date is there, actual relocation charge, actual extra validity, and actual landline charge. So you have understood that this is our incoming data record file, which will come on daily basis. And the system based rule based system will apply checks, and will flag the discrepancies according to our logic. So I already told you the logic. is very straightforward for three KRIs, and one is revenue calculation that I will show you. So let me go to the screen again. So you can see here. Okay, so another file is from to date file, that is from to date report. Here it is, from to date report. So yeah, it has again customer IDs because this is our common column in every file. Base plan charge is there, total validity is there, actual plan validity is there. So this we will make use of when, and then there is revenue file. I showed you here there is some daily revenue file which is coming. So this is this Excel file. Again, we have same column, customer ID, common column. Deferred revenue is there. Current day date is there. So what have happened when I was working with D2H company. So this file, these all files comes daily. So current date correspond means today is even some 19th February something, but we will take this date from this file only, because then I have to design every file, and I have to put that date. I mean, I have to change the date, so we will just pull the date from here. Unnecessarily, I have to change the date. The file should be remain same, but we will pull the date from here. Just for calculation purpose we need. So it has the current revenue. So this revenue, this field, we need to audit. We need to, we will set up this formula to make another column, calculated revenue, which is made by our formula. Means rule based system, we have put that formula. So I will show you, because earlier we will when I started my career, in revenue assurance I was doing in Excel, because for knowing purpose, then we automate in the system itself. So let me show you what is the formula. Okay, so this is the steps to calculate revenue. We have to select the base plan from to date report and remove any add-on to focus on the core plans. Let's go to from to date report. Okay, this is one. So it is saying that you have to select the base plan. Let me select the base plan. So base plan is same for everyone. So no filter has to be applied. Then remove any add-ons to focus on the core plan. So this is not needed because we have don't have any add-ons. In this we have only base plan, that is only single plan. So for representation purpose, this is very easy. Then second step is identify discrepancy in validity. We have to check where the total validity cases from to date report is less than the actual plan validity. Okay, so from to date report we are here, same report. What we have to do is we have to check the where the total validity is less than the actual plan validity. Okay, let me show you. So total validity column is there. You can understand actual plan validity column is there. So the it is we have to do is where total validity is less than the actual plan validity. Let me make a column difference equal to this. If this is less than this, simply we will hit it false. We have to select the true cases. So let me just check the two cases are there. Yeah, there are at least 15 cases are there. So we have recognized the two cases. Then what it is saying? It is saying that we will take the deferred revenue from the daily revenue file for the current date. Okay, so from daily revenue file we have to check for the current date, and then we have to apply this formula. Firstly, we have to check the deferred revenue. Okay, so what we will do is when we have already identified this case, so we will go to our this one file. This is revenue file. we have to take deferred revenue from here. Okay, so what we will do, we will just go to the file which is our daily file record file, this one combined record file. Firstly, we will spool the cases which we want to address from to date report. Only true cases we need to address. So let me just make a case column over here. Sorry, I will say qualified cases. Okay, so just we will spool this, and we'll just take the data from here to there. So see, so now we have taken the cases which needs to be true, and we have matched the data from there, and then we need deferred revenue for true cases. So simply I will write deferred revenue, and from I will match it from revenue column, revenue file, this one. Simple, I have to case deferred revenue, so that column I will match as per customer ID. See, it is also imported here. Then what is being stated by the calculation, that we have to calculate the remaining days, and remaining days is equal to expiry date minus current date plus 1. So I will make a column for remaining days as well, remaining days, and the formula is expiry date minus current date plus 1. So why I am doing here, now you can know that expiry date is there. So this is our daily incoming record file, so calculation should be applied on this, because the expiry date is there. So expiry date minus current date plus 1. Okay, so firstly what we will do expiry date minus current date. Current date we are taking, I told you, from that file, revenue data file. So we will take this date and plus 1. Our calculation is completed. See, remaining days are coming here now. Okay, but what we need is, again we have to go to the calculation formula, and we have to calculate revenue. That is, calculated revenue will be deferred revenue over remaining days. So I will just make another column of calculated revenue. Okay, and we will just divide the deferred revenue divided by remaining days as per our formula. Very good, very good. What a beauty! What a beauty! This is Excel thing. This is way back when systems were automated system was not there, and everything we have to do manually in Excel. So now, but we need qualified cases. So I will exclude the false, and true cases are there. Only 15 cases we have to address now. So what happened is, calculated revenue is there, and we have to spool the current revenue to check. So one second, we have to just make a current revenue column from the revenue file that was being left. So this is the last part. Here, this revenue we need. Oh wow! Just now that everything we have here, we have to take the qualified cases which are true, and those 15 cases we have to compare now these two columns, current revenue and calculating. This is all manual. This will be done automatic by the system generated reports, KRIs I mean. But for showing purpose I will show you that current revenue are having problem, and we are doing audit, and audit is like this only. When we have this column calculated that we have made manually, so this is totally correct. Any discrepancy from this, because this is coming through some other source, will be highlighted as discrepancy, any difference. So what I will do over here, these are very long figure. After decimal there are so many figures, so I will just make a formula. Let's compare it. If I will round the two decimals, if this number two for after decimal two decimal, then okay, and then I have to compare it with which one, this one. Again round I have to do, and then I have to give this number. Okay, so yeah, if it is true then show true, and if it is false then show false. Okay, yeah, got it. So yeah, see, oh, wow. So this is our status, final status, that these values are true and this much is false. So this will done by ML also, but for demonstration purpose, I showed you manual. So we will remember this. These are how much? These are six cases of false discrepancies. Six cases are discrepancies in revenue audit data file reconciliation report. Okay, so that's manual thing in Excel. We will now hit the code. Okay, so here we are on coding screen, and you can see here calculation based evaluations for KRIs report. Okay, so yeah, 4 KRIs are there, and I already told you that these three files will be used. So you can see here for the relocation report function, already we have given the value of $50. $50 less than or greater than, they will attract the cases to be flagged as discrepancy, means exception. And similarly for extra validity 10 more than 10 days, will be given the status of discrepancy. And we can also put CSV files, or to compare if we have some metrics in CSV files. So but for the presentation purpose I told you that we are checking for $50 for relocation, 10 days for extra validity report. And for revenue reconciliation report, we can see here that we are taking the this one, current date from that file, revenue file, and then remaining days we are doing all the calculation that I showed you in Excel file. And then landline report, you can see here $5 charge will be checked. And again, less than or greater than, will make the status of discrepancy and flag, and those cases will be flagged. Okay, let's run this code. Okay, so I have already, you can see here that the code is started running. Now I will go to the email screen and wait for the reports to come. It will come anytime now. See, wow, what a beauty! System generated. Let all the four reports come, and then we will check, and whether it is correct or not. See, relocation charges. So relocation charges, $50 is the amount. Less than or greater than will flag it. So see, 60 45, all the cases of the not 50. So discrepancies exceptions found are 31 cases. What it is saying, it is, dear user, this is system generated D2H audit report for this one, as in subject line also 19 Feb 2025. Why? Because I have given the encode that put the current date. So yeah, that's regarding recollection charges, reconciliation report. So these are the cases I already told you, but there is also CSV file attached. In those, there are correct charge cases as well. But see, $50 wherever is a $50, it is showing correctly charged. But in email body, we want to show only those who are not correct. So that's why it has been shown. So for extra validity, more than 10 days cases will be shown as discrepancy. So here these are all discrepancies, and how much is that? Exceptions found are 21 cases. Similarly for revenue charges, over WTC, the data is there: customer ID, remaining days, deferred revenue, current revenue, and calculated revenue. This is being compared, and I told you in Excel manual 6 cases were there. So one, two, three, four. Why I'm counting? It is discrepancies, exceptions found 6. Wow, what a beauty! So see, so this is rule based. Okay, right? So I told you there are some problems also with these, and that ML will address. Firstly, I want to show you through rule based. So this revenue report also has been done. This is revenue charge reconciliation report, system generated, and last report is landline charge reconciliation report, in which $5 was the actual amount has to be deducted, but less than or greater than will attract the status to be discrepancy. So yeah, 4 6, you can see for $6 exceptions are 28. And if I click this, wherever the value is $5, it will say correctly charged. Okay, so excellent. This much has been done. We will now check the machine learning based reports to compare with this one. Okay. Okay, so now we will use machine learning for KRI classification. The classification model will be used for this KRI generation. So goal is to identify if a customer is again same correctly charged or under or overcharged, means discrepancy. So ML model used for classification, there are stacking model. Firstly, base models all classifiers. Classifier means 0 1, true false. In our case, correct or discrepancy. So these are qualifier: random forest, MLP. MLP is a part of artificial neural network plus gradient boosting plus extra T plus cat boost, and final model as logistic regression. Okay, so this will be used for 3 KRIs rather than one, that is revenue report reconciliation. So for that we have another stacking model which have all classifier again. One side there are 4 MLP, multi-layer perceptron, which is a part of artificial neural network, and other base model 2 are random forest, gradient boosting, extra T plus cat boost, and final model is again logistic regression. So it will detect overcharging and discrepancy based on variance analysis. ML decision will be given as correctly charged or discrepancy because it is a classification model. So you can see that how much models are used. So there is no room for errors. Okay, let's check, and we'll just. Okay, so here we are in coding screen. So you can see here. This is the code where models are defined and the training data has been given for all the KRIs. So you can see here base models, same I told you, multiple classifier, random forest, gradient boosting, and all extra tree and cat boost classifier. For first for 3 reports, which are report relocation, validity, and landline, and similarly for revenue reconciliation report, these are the base model. You can see MLP 1 2 3 4, 4 MLP classifier which are part of ANN model, and then random forest, gradient boosting, extra tree, and cat. What I have done, I have already ran that code and I have saved the model file because it will be very easy to. We have already saved the model file, then it will be less time consuming to just generate the reports. Same three files are being used, and then we will generate the reports, but this will be machine learning based. So you can see in no time, in a very less time, it will generate. So also I will show you the email window. So we already have these correct system generated reports, and we will compare the stat with the machine learning. Okay, so let me hit this code. I mean run this code now. Okay, so loading models and scalars, you can see on the coding screen, output screen. It is coming. It is loading models and scalars. Then the predictions will be made, and the report will be generated. Just check the email window and come back. And in the meantime, I will show. Yeah, same. Four reports will be attached to the email part, and I will show you that there. Yeah, see the already, wow. What about all the stats are being published and prediction process completed successfully. That's I want to show you that this will be happen in no time. I mean very less time if the already model files are saved and loaded now. Email sent. So we'll go to the coding screen, and yeah, you can see we can see here. Wow, ML based D2H audit report, relocation charges, recalculation, extra validity, revenue, all four have arrived. Let's start with landline charges. How much? See, okay, so already the same code discrepancy cases will be highlighted in the email body. So what it said, ML based D2H audit report. This date is this much date. This date and landline charges reconciliation report. Dear user, this is a ML generated D2H audit report for this date regarding landline charges reconciliation report. Kindly find the CSV report attached with this mail. Discrepancies exception found are 28 cases. Recommendation: please review the attached report and take necessary corrective action immediately. So 28 cases, okay, and the CSV file is there. So we will just check, go back and check for this landline charges system generated report was how much? 28. So 28. Wow, beauty, 28. Same, correctly identified. Then we will go to extra validity. This is ML generated for extra, extra validity reconciliation report. How much? 21. Discrepancy exceptions found 21. These are the exceptions, and this is the recommendation. And we will just check the count 21 for extra validity reconciliation report. 21 should be there for extra validity here. 21 in rule base also that was 21. So this one also correct. Now relocation charges reconciliation report, discrepancies found, 31 cases are found there. Okay, so we go to landline. Sorry, which was there? Okay. Relocation 31. So same, 31 there, and 31 for ML based D2H report relocation charges. Exceptions are 31. Rest last is revenue. Oh wow, what a beauty! See, ML based D2H report. This one 19th Feb. Revenue charges cancellation report. Dear user, ML generated or D2H report. Okay, discrepancies exception found six. So six was there. I told you in Excel also, in system based also. I mean rule based also. See predicted label. Wow, what a beauty! I told you, zero is for incorrect, one is for correct, but only zero will be showing in email body. So these six cases ending with customer ID to 26, 28, and up to 38 are shown. And this is the current revenue that was in incoming record file. I mean that is coming in daily revenue. Sorry, this one daily revenue file. So this one column ML based algorithm has compared this, and when comparing with this and the predict label, it has to generate that whether it is correct or not. So this is the calculated revenue. This is system based calculation. Means the classification model will just predict the 0 or 1. Let me show you. You will get an idea now. This one, because it has both 1 and 0 cases. See, 1 are correctly charged and 0 is the discrepancy. So that's why in email body 0 cases were only coming. So 0 stands for discrepancy. But you can see here, the thing is, I will show you. You can see that how closely this case ending with 28, I mean customer ID ending with 28 1000028, current revenue is 6.68, and calculated revenue is 6.78. Matlab, means this one is calculation based, but our model, as was trained. This column I have added for showing purpose. This was not needed, but I want to compare the results and I want to show you. So these are the cases which are incorrect, because this they see current revenue is $12.90, but it has to be $7.02 according to our old KRI as well. This is the simple formula that we used in calculate rule based KRI. But I add this column to show you that how good is this classification model. See, for this case, the difference is 10 cents only, 6.68, and formula is 6.78. But our model has already predicted, not on this basis, but on the training data, it has predicted it as a incorrect, 0 discrepancy. Why? Now I will tell you. I will go to the coding screen and I will tell you. This is the prediction code and this is the training code. So when we design this revenue data KRI, you can see here we have given the tolerance of 0, sorry, 1%. See here, I have not told you before, because I want to first want to show you the results, and then 1%, and this is 1%. This is not under 1%. So more than 1%, it will show a discrepancy. So see, this is some logic we have already given for classification model, that classification has to learn. So wow, what a beauty. Okay, so if I ever just download this in front of you, sorry, download, download, I will show you that how this works. So we have trained the model to to tolerance of 1%, and I even open this file. Okay, don't angry on me. It's just opening. System is being heavily occupied with these data recording and models. I mean, these codes, heavy codes. Okay, so here is the data attached with the email. So see, for particularly this case, I told you, for discrepancy case, I will highlight this, where only 10 cents and the model was able to judge between right and wrong. See, Ah, this one 6.68, 6.78. So I told you this column is being put in by me, but model has already just through the tolerance level given in the training data, and it has understood that this is incorrect, and I will just, and what I'm doing is I'm showing you that I'm not making this up. I'm just giving you, let's have the formula. So if current revenue minus calculated revenue divided by current revenue into 100, and see, the tolerance is 1.49, means more than 1%. And I what I told you, let me show it to in the number format also. Now I told you the tolerance level is plus or minus 1%. If it is more than 1%, we have given that in training code here. This one there, you can see. So the model has to learn that more than 1%. I have the case should be flagged, and that's why at that level the labels were being of 0 1 at that time. These labels, this is the predicted labels, but in training labels also we have put the tolerance of 1%. So it has learned the same way. So I told you that these ML models are very very valuable, and they learn from the hidden pattern as well. But this was being given, so that's why they always stick to the rules whatever they have been trained upon. uh, they will follow. So similarly, if you want to see the tolerance level, you can see here for other discrepancy cases, so much. Only 1% something, 1.5% something is this, then 30%, 62%, 18%, 61%. So it has to highlight those cases. If I you can see here 45.58, and if I move forward for the correct cases, you can see here 0 0 0 0. So this is live. I'm not making this up. Tolerance level is 0 0 0. So why will it flag it as a discrepancy? So that's why correctly charged. Wow, what a beauty, absolute beauty of machine learning models or AI models. So this is something, when you are a subject matter expert, you can design this way, and you can understand the model behavior. That's why I put so much of ML models in that. That's the margin of error will be negligible. Okay, and same for this. I will show you through regression model also, where we will generate these values. These will generate these values. Main model, regression model, will predict these values. It will not calculate. This is manual calculation. I showed you for I add this column for for representation purpose, but actually now regression model will predict these values little bit upside down, but we will adjust accordingly. And then the main thing is to fine tune the model to be as correct as these this formula values. So we will show it in now next. Okay, so now we will go towards the regression model. So revenue reconciliation using regression, the goal is to predict expected revenue and compare with actual revenue to flag discrepancies. So we will predict the revenue values now. I told you that this is not formula based. We will predict values. This is model based predictions. So what models we have used: XGB regressor plus CatBoost as primary models, and the secondary models are there also for residual. All regression models are there. Means on that classification, we are using classification models. Now we are using all regression models. So you can see here LGBM, RF, random forest, and MLP is also there, and EET extra tree, and hist model, and then this one is also there, tabnet plus XGB, or a very highly finance model predicts expected revenue dynamically instead of fixed rules. That is the benefit. Okay, and if we go to the next code, you can see here the approach for classification. I already showed flags revenue discrepancies as correctly charged discrepant, quick fraud detection. You can say also that uh, quick correctly versus discrepancy classification. Regression model predicts actual revenue and finds mismatches. Actual revenue is in also we both the models have their own strength. I will show you that in uh, in next how these models have have their strengths. So continuous revenue tracking. So regression models are very good if you want to forecast something, like you want to forecast what will be the value of the customer which will be churned. So the classification model will tell the count that 1700 something subscriber will be are at risk at next month, and regression model will tell that 2,36,000 is the dollar is the estimate that you will lost the revenue. So all models have their own strengths. So okay, so this let me go to the next slide also. So I will tell you the key challenges in implementing, this regression models for audits. That feature selection was very difficult. Even this see this much of features we have used: remaining days, deferred revenue, revenue difference, validity, utilization ratio, revenue change, 7 day rolling change. For 7 days we are watching log deferred revenue. We have checked. We are checking revenue change in 30 days, and revenue change 7 days, revenue 30 days. So we are checking this also. LF score is we are checking. I will explain this in next challenges. Okay, so variance computation, fixed versus dynamic tolerance. There was n number. I mean, there are so many. There were so many challenges was there, uncountable challenges. Regression model tuning, handling revenue deviations and expected fluctuation. I will tell you in a very summarized way. And this is something residual distribution plot. This is the last fine tune model have produced. So you can see here also the residual distribution plot is saying that now it is balanced. So you can see plus minus values are towards the same uh, range. Yeah. So it should be like that. Okay, let me. Okay, so let's look at the coding screen now. Fine tuning for this, regression model has begun much more before this code, and I struggle to find what are the features that are beneficial for this regression model to predict the revenue as close to the calculated revenue. So you can see here. I already showed you that features are here, which we are using: deferred revenue, remaining days, revenue difference, log deferred revenue, and other as well. I will explain them accordingly. So what happened is firstly I struggled to get which features are essential. Then we have to fine tune. You can see here the in this plot you can see here all data points are at the perfect prediction, which is this red fitted line. But this case, this customer ID, this is far, behind I mean, far away from the perfect prediction. Why? Because I will show you. See, this is the file ML based revenue audit report. When I ran this code, this file has been generated. So this one is this. The first thing is between we will compare the current revenue lastly, but firstly the final revenue, which is our predicted revenue, it should be come close to the calculated revenue. This is the column. This is the manual, formula based column, which is correct. So we have to this column we have to all the values for this column should be come close to this, and we are taking the 2% tolerance margin. But you can see for this case only one ending with two 1000002. The calculated revenue is 12.12 cent something. Here it is $11.06 something. Yeah, so tolerance level we have set 2%, and you can see here, yeah, in this code 2% here tolerance level is there 2%. So more than 2% it will show as discrepancy. So the main aim is first to, as I told you, to make these values close less than 2%. If I show you the formula, I'm not making this up. Simply we will minus calculated revenue final calculated revenue minus final revenue, and then divided by again calculated revenue into 100. See, 8% something. Let me show you whether that's why then you will know why they come as correctly charged. So see, this one only uh, have 8% something. I will just increase the size for a better understanding. Okay, see now 8.73. Only this for this case customer ID we are struggling. All are under 2%. See, 0.02. If greater than 2%, flag it as discrepancy. So 2% borderline. All other 0.98 less than 1. 2% minus 2% minus 2% borderline, minus 1%. So yeah, this is I told you, the more fine tuning you have to do, then this will come closer. So and now we'll quickly see the other codes, and we will see the final code. See, this time this is far away. Then I do some more changes, and you can see here. Then it come closer like this. Okay, and then what happened is I will tell you. Firstly, the models are there are XGV model and a CAD model are primary model. And what we do, we introduced alpha, optimize alpha. Firstly, we give a default value of 0.5, and then we automate it like this from 0.1.0. I mean from 0.1 to 90 from 0.10 to 90%. It will check which is the best alpha. It will return that value, and then there will be some weighted revenue calculation, 60% for first model, 40% for second model, and then the tolerance level of 2% will be uh, given to compare the final revenue and the calculated revenue. Remember, calculated revenue is the correct calculation as per formula, old formulas, and final revenue is the model predicting this value. So we have to. you know firstly, the main goal is to make final revenue values as close to the calculated revenues less than 2% tolerance. So here, uh, when I tried again, then I will show you this. The value becomes this one, 11.87. So it is more closer to 12.12. See, before that it was 11.06 here, and it is uh, very far behind, very much difference between 12.12 and 11.06. Again, it becomes 11.87, much closer to 12.12. And then what happened is, okay, so what happens, yeah. So I went ahead and, I put that, primary models to optimize through Bayesian optimization. This is XGB model, this is CAT model, and we have put parameters to optimize through Bayesian optimization. So it will optimize, and there are other models like MLP, which is part of an NN model, and random forest machine learning model, and then we will give it final model as linear regression. This stacked model will be trained on the errors done by XGB and CAD model. So for those errors, these models will be trained, and they will then again predict the error. So we will add those error lastly to the revenues prediction done by these two paradigm models. So you can see here, and residual analysis is there, final revenue minus calculated revenue, and this will make the residual stacked, and then we will make the tolerance level is simply 2%. But after making this also, I will show you what happened. The see, even after this, also the you can see here, this is a histogram of residual. So this much features we have used. LOV score is also there. So LOV is local outlier factor, and it produces score. And score is close to one. It indicates that this data point is similar to its neighbor. So we have already given k neighbors. So that's why it will check the score, as I told you. If it is close to one, it means that it is close. This data point is similar to its neighbor, and if significantly greater than one, then the indicates that the data point is outlier. So it is very good in anomaly detection. So that's why I told you that I struggle to firstly find those features which are important in this regression model to predict the continuous values as close to the calculated revenue. So now I will tell you that, see, again we are struggling. See this data point. This is the same customer ID that ending with that was 100002. That is far uh, from this red dotted line, which is perfect prediction. All those are very close now, but still we are struggling without that customer ID. So these plots shows you the main difference. So even this is the same customer ID is more. This is far behind. It is above the level, the value -3, and these all are towards the within the range of 0 to 1. You can see here. Yeah. So, and this is the last code. I With the last code, I was able to do it. So what happened is, samely, but I just changed the weighted calculation of alpha, where that we have given automated to equal to both models. Then I changed the models to these models I already told you. So these one, two, three, four, five, six models plus meta model as XGB regressor. So from that, I was able to pull these things off. So then what happened, I will tell you. See, wow, what a beauty. Now if we see, so these are the features which you can know which features are, which model is giving high importance. So, positive side towards point 0.8, this remaining days, deferred revenue, high values to bend between zero point 0.4 and zero point 0.6. Similarly, all others, some are on borderline. So now you can see the residual distribution plot. From this plot, you can see now that we have balanced the errors. Residual means errors. So little bit towards minus, you can see uh, between 2 to 2.5%, and from plus from 0 to 3.5% something. So yeah, this is something balanced. So our final prediction model is ready. I have already trained and saved it. So now we don't we waste time, and I have already deleted all the other reports. So because this is the same for only revenue audit report, this regression model will uh, generate the revenue. So you can see and understand now that calculated revenue will be there, current revenue will be there, one more column will be added. This predicted level will not be there because this is a regression model. So instead of 0 or 1, the values will be uh, like this. So the final revenue column will be added and the values or dollar values will be there, and we will compare those with the current revenue. So it should also flag that expenses count should be 6. So this is the main problem, that it has to predict the values as close to the calculated revenue. Then only we can differentiate between current revenue and final revenue. Now I will run the code. Okay, so the code has started running, and it will show the stats as well. This is, I will tell you that this fine tuning requires subject matter expert, because you have to fine tune the model. I told you through the feature selection, and then there were problems with the fine tuning of through the variance was there, computation, fixed versus dynamic tolerance, handling revenue deviations and unexpected fluctuations. So but at last, the things were being pulled off. So right now we are waiting. Let's just refresh the email screen as well. Okay, so yeah. So yeah, I want to tell you also that ML revenue. I will explain this. ML revenue report saved. It has been generated and prediction process completed successfully. Email sent successfully. Just go to the, wow, what a beauty. See, we will just compare these reports: revenue, charge reconciliation, classification based, and ML regression based. So if I open this now, wow, what a beauty. See, this is an ML generated D2H audit report, revenue charge reconciliation report. Okay, regression based. Dispense is 6. Bang on. See, let's go to this. Dispense is 6. Okay, same cases 26 till 38, and here also, oh, sorry, 26 till 38. And now we will compare. See, deferred revenue is also there. Current revenue, that is, that we have to check against that our final revenue. This is the column that our regression model has predicted the values, and this calculated revenue is the correct one. This is the old calculation based. So see now, final revenue $7, 7.02 discrepancy. Okay, I told you. And 6.78, sorry, this one we have to compare 12.90 and 7 discrepancy, 6.78 and 6.68. See, 10% only. Then also discrepancy 9.29, 6.45 discrepancy, 14.29. These are much discrepancy, 5.51, 6.29. But I was telling that how close it has, to the actual calculation, a calculation based revenue, how close model has predicted the values. $7 towards the 7.02, 6.78, 6.0, same. Oh my god, 6.45, 6. Same. This is prediction values, 5.38, same, 5.38, 5.15, 5.15, same, 5.07, 5.07. So can you believe now? Can you believe it? This prediction model, how close, it has, predicted the revenue values. So I will tell you now. I will go to the code part also. Yeah. So see, when I tell you this now, we have given the tolerance level of 2%. See, but you will see, you will ask, if it is 2%, then how this customer ID 1000228, in which current revenue is 6.68 and the model predicted 6.78, which is accurate to the calculation based methodology, calculation based revenue. So you are saying 2% is tolerance level, then this is less than 2%. So why it has not said it as correct rather than discrepancy? Okay, let me download this file also. I will show you. The questions will be asked, addressed. I will open the file regression because it has both, cases, correctly charged and discrepancy now. Sorry. Okay. So you are saying that, you see, 11.91. The model predicted this value 11.91. Current revenue is 12.12. Then also correctly charged. You will say, what is this? How it is correctly charged? Why? Because we have given 2% tolerance. More than 2%, you will flag it as discrepancy. Sorry. So let me minus this from this, and if I divide again this and into 100, and I will check for all, and I will change the format to number. See, uh, less than 2%. And tolerance level, I told you, if it's less than 2%, then it is correctly charged. So for all these, I will highlight it as green. These are correctly charged. Okay. So for all these cases, you can see the tolerance level is less than 2%. For these all are zero. So they have to be, the status has to be correctly charged. But for this case also, when you are asking that predicted value by model is $11.91 and the current revenue is 12.12, then how it is correctly charged? Why? Because tolerance level is less than 2%, and I have already given that condition. That's why it has been correctly charged. But then again, one customer ID is creating problem. This one, well, I highlight well this one. Why? See, current revenue is 6.68 and final revenue 6.78, and the tolerance level becomes less than 2%. So now your question is why this has not been flagged as you know correctly charged, because you have given the logic. If tolerance level is less than 2%, then all will be correctly charged. If it is more than 2%, then it will be discrepancy. So see, correct. I This one is correct because 45%, 30% something, 62% something, 18% something, 61% something. So all are above 2%, then yeah, it is correct that the model, that status is discrepancy. But for this, it is under 2% though. So why it has not been flagged as correctly charged? Because we have given the condition of 2% as tolerance level, plus minus. So within, less than plus 2% correctly charged. So less than minus 2%, it should also be correctly charged. But but the status is discrepancy. I will tell you now why. See there, I told you na, there is a, the we always use uh, categorize revenue. I mean, we always use that auto threshold formula, uh, which will calculate the average and mean. So for that, for this also, no, sorry, here in the prediction code, yeah, here calculate tolerance threshold. So what is it is saying that average, it will check for average, it will check for standard deviation, and if variance is less than equal to 10%, it will use average mean. Otherwise, it will use average plus standard deviation. So now I have already put in the debug command here. You can see here mean value, I mean average revenue value was 6.99 and standard deviation was 1.62. So variance was to 23.19%, which is greater than 10%. So the condition will become that add average plus standard deviation. That's why 6.99 plus 1.62 become 8.67. Okay, based on this much variance. So above this value 8.61, now you can see above this value 8.61, tolerance level will be 2%. I've already given this condition. This you can do when you know how your model behaves. So here, okay, here you can see here 2%. If current revenue is greater than the threshold, else 1%. So the value of 8.61 something. What is the value? 8.61 here come. Let's go back to the our. You can see here if it is greater than 8.67, then 2%. But this value, is it greater than 8.61? No. This is $6.78. 8.61 is the threshold. So for lower revenues, the tolerance level is 1%. That's why it is more than 1%. So it flag it as discrepancy. So see, for this correctly, I mean more than 8.61, it becomes 2%. For less than 8.61, it becomes 1%. So that's why it was able to find the status that is correct discrepancy. So that's why if we go back, you can see, wow, what a beauty. All six cases are identified by the regression model itself, which is predicting the final revenue, and then we are comparing the final revenue versus the current revenue. And we have given the auto threshold, which helps in making the status column. So the tolerance threshold is the function that is helping us. So this ends the project now, and lastly, I will tell you, see that future forecasting can be done by both regression and classification model, and it is very simple. When you have something like this, when you can, regression model will produce the values, and similarly, and classification model will predict the status, what will be, who's gonna churn, who's gonna not churn, and then you can combine the both models output, and you can make the report like this. If you do Power BI or W, you can see that 1700 at risk subscribers will be there at next month, and this will be the projected loss, like something to $38,000 will in next quarter will be the projected loss. We are going quarterly, then 1700 at risk subscriber are quarterly. Next quarter will be out of your network. So if I zoom this, expand this, I mean, so classification model is focused on subscriber churn count, like this 1700 subscriber is the predicted value. Business impact is helps identify potential churn risk and take preventive actions when you know the count. And regression model, it will estimate the revenue loss, that this much will be your loss for next quarter. Helps forecast financial impact and design revenue saving strategies. So in this way, you can use regression and classification models, which have their own strength, as I told you. So guys, this is the closing round. Now signing off. Please take care of yourself. Okay, bye bye.